In this class we will see the empirical relation between SPT. SPT means standard penetration test and several soil properties. Several soil properties means gamma saturated, that is density of the soil, saturated density. Q is the compressive strength of the soil. C is called as a cohesion or shear strength of the soil. The consistency of the soil can be defined in 3 terms. One is soft, another is stiff, the third one is hard. I will be giving different types of classification from different textbooks. There are certain field identification that is possible. One is easily penetrated several centimeters by thumb. There is very soft clay is also there, that is easily penetrated, that is less than 2. This is the type of soil in which we are going to design the diaphragm wall. N value is less than 2, that means the SP2 spoon will go on its own weight without any blows. So, let me explain what do they do, what kind of test they do to get the standard penetration test. See, suppose this is your bed. This can be done below also, below seabed also, but on land how they do I will tell. They will go very deep. Generally they go about 30 meter deep for offshore structures. Generally for about 30 meter they do the test. They do the test at different intervals, the SPT test. Typically the interval is about 1.5 meters. But this varies. Suppose there is a layer changing, then the layer is only 1 meter thick, and they do at that particular layer. What they do is, there is a tripod through which there is a spoon, it comes here, there is a spoon here, they raise the spoon and drop it. There are some standard weight of the spoon is there, standard height where they are lifting is there, they lower it, that is one blow, then again another blow, third blow, fourth blow, like that. It goes for about 15 centimeters. Before coming to this level they will remove the soil here. So, they bore it and remove the soil, that means the soil here will be disturbed. So, they neglect the first 15 centimeter reading, then they go to the next 15 centimeter, then they go to the next 15 centimeter, 15 centimeter they write, let us say about 7, this as 12, then SPT N value is 19. This is for 15 centimeter and 15 centimeter. Then they bore up to this, then they conduct at the next point, like that they continue to do it. They do other tests also, they take the sample, they do a triaxial strength, so many other studies they do it, but mainly we rely on this SPTN test. Any doubts in SPTN test? Standard penetration test. Standard means there is a standard, standard means weight of the spoon is a standard, procedure is a standard. Penetration means how much it penetrates, 15 centimeter. Suppose you go on hitting 100 blows and there is no penetration, do not continue to do it, you stop it. Maximum to do for 100 blows, 100 blows 10 centimeters of penetration, for 30 centimeter SPTN value will be 300. If it is less than 2, generally the saturated density will be lesser. C value is taken as 6 times N in kilonewton per meter square, 6 times N value is taken as C value, 6 into 2 is 12, this is 2 to 4, that is 12 to 24, 4 to 8, 24 to 48. So, 6 times N will be taken as C, Q will be 2C multiplied by this 2. As the consistency of the soil increases, the density of the soil also will be increased. Saturated density means you take the sample, the sand it can be easily explained, you pour water, it will take till saturation certain quantity of water, then take the density, that is soil is a 3 phase medium, you will have soil particles, water and air. If the air voids are completely filled with water, then it is a saturated density. Rock is similar to clay soil only, the N value can go more than 100, it may go to 400, 500 like that. So, here also the same thing only is given in a different format. So, here very soft, medium, stiff, very stiff and hard, that is what is written here. So, you can very easily understand this. Generally C greater than 200 kilopascal is some kind of weak rock. Then we have other type of soil, that is a sand. Sand will have 5 values, that is given here, different type of sand. Sand and silt are same. In the sense, silt will have particle size smaller than the sand. We may have clay silt in which it will have a cohesion. If you have a sandy silt, it will not have any cohesion. The 5 values are given, varying from 27 degrees to 50 degrees. The gravel is 50 degree, I do not think this is correct, it may not be so high, maximum is 35, 38 only. Then we have Poisson's ratio. You know what is Poisson's ratio? What is Poisson's ratio? Lateral strain to longitudinal strain. Generally it is about 0.3. This is required because when you do the analysis, the earth pressure is a lateral earth pressure, and this lateral earth pressure, when you are trying to find out, this has some influence of Poisson's ratio. Another thing is when you do some analysis, we estimate the spring constant, that is the reaction by the soil. Passive force we cannot estimate, we have to find out the reaction, for which we idealize that by a spring element. For calculating that also we need the Poisson's ratio. Generally Poisson's ratio is less than 0.3 for soil, and for clay it is between 0.1 to 0.3, sand it is between 0.15 to 0.4. Rock is similar to concrete, it can vary from 0.1 to 0.4. 0.1 is a very weak rock. Concrete is between 0.15 to 0.25, steel is between 0.28 to 0.31. When you want to calculate the spring constant, we also need Young's modulus. What is Young's modulus? Stress by strain. So, when you want to find out the reaction by the soil, we need the spring force. Spring force is related to stress, stress is related to Young's modulus. So, we have SPT N value versus Young's modulus. N value is given in this axis up to 50, and this is the Young's modulus in kg per centimeter square. You can take this value. What is the Young's modulus of concrete? 20 GPa. It is related to the grade of concrete. 5000 into root of FCK, that is the Young's modulus of concrete. And steel, that is a constant value, whatever be the grade of steel. So, just like clay, where we have given different properties, here also we are giving different properties of sand. We classify the sand as very loose, medium dense and very dense. I explained about this SPT N value. As you see here, a very small N value less than 4, we have very loose, 10 to 30 is medium dense, greater than 50 is very dense. Sand liquefies, when you have a earthquake, then the sand liquefies. SPT N value less than 10, then it is a very loose sand, then it liquefies. Then you have to do ground improvement for that. Here we are giving the dry unit weight of soil, that means you take the sand sample and dry it in the oven, you do not have any water, 3 phase medium you have only sand particle and voids, then you calculate the weight, that is your dry unit weight. It is less than 14, 16 to 18 and this is greater than 20. Friction angle, this is less than 30, this is greater than 38, the limit is around 38 only. Then we will go to the analysis of the structure, what has failed. Nearby there was another structure that was coming up, for which we have designed the structure. This is a diaphragm wall, this is an anchor wall, this is a pile, and we have a cross beam connecting them. There are some beams here placed and another beam here, retaining beam. There are 2 beams which are crane beams. There is a fascia beam which is used to fix the fender. This shows the 3D idealization of the structure using StatPro, which is standard software used for structural analysis and design. We will be seeing this in next class, how to generate the data for this. This is a T diaphragm wall, this is a circular pile, it is a rectangular anchor wall, there is a beam which is connecting. We have taken a typical 2D structure for the analysis. It shows the borehole details. The sea side, this side is the land side. So, you have a T diaphragm wall. I will tell you why we are using T diaphragm wall, because it needs more moment of inertia. So, this formula you remember, this is the, you try to understand how the derivation is, what are the limitations, what are the assumptions of this formula. Whenever we want to do structural analysis, we will be using all these parameters. One is the bending moment, another is moment of inertia, stress, y is the distance to the extreme fiber, E is the Young's modulus, R is the radius of gyration. All these things are important. Mainly you have to check for deflection as well as stresses in the member. If you do side by side like this, this goes as a continuous structure, it will retain the soil. Here you will be dredging up to minus 17, here the top level may be plus 4 approximately. So, here it is minus 17, it is plus 4, that means inside this portion there is some soil which will be retained by this structure. So, when we started doing this analysis, we have taken the soil profile exactly at the location of the berth. When we did the soil investigation, top level was 3.69. There was a original ground level which was at plus 1.1. Above that they used some filling, so the filled soil, the gamma is 18, N value is from 22 to 31. So, here it is about 2.5 meters. They did 2-3 tests here, each point you will have different results. The range is 22 to 31. We assume the groundwater level at this plus 1.1. need not have to coincide with this, but sometimes we may have to it may coincide. Then we have sand up to -4, plus 0 0 is given only for some just to mark the level only, whereas the soil from 1.1 to -4 is sandy soil. It has a submerged density of 8 kilonewton per meter cube. Above the water level we give the dry density or natural density, below that we give the submerged density. Phi value is given as 30 degrees. We have calculated the K 1 minus sin phi by 1 plus sin phi, that is 0.33. -4 to -17 we have marine clay, N value is 1 to 3, the density is also very less 5.1 saturated density, I am sorry, submerged density. Phi value is 0, K is equal to 1, C is equal to 12 kilonewton per meter square. Young's modulus for this soil is 5000 kilonewton per meter square. Then we have a stiff clay, N is equal to 20, the density is the same, it has some component, some sandy clay only, it has some phi value also. K is, it is not a clay alone, it is a sandy clay. Then we have the cohesion value given as 120 kilonewton per meter square, Young's modulus is 30,000 kilonewton per meter square. Then we have highly weathered rock, Young's modulus is 80,000. Here we have written CR, gamma is 5.1, phi is 0 degree, K is 1, C is 460 kilonewton per meter square. What is CR? What is CR? What is RQD? CR means it is core recovery. Suppose if you are using this SPT test, suppose you have encountered some rock here, you cannot do SPT test. What you do is you go here and take a rock core, take a core of rock, and what happens is, suppose you take a core of about 1 meter, what happens is there will be some pieces of rock here, some pieces of rock here, some pieces of rock here. Let us say it is 12 centimeter, it is 6 centimeter, it is 9 centimeter. Core recovery is 12 plus 6, 9 plus divided by 100, that is 27%. RQD means rock quality designation, that is any piece more than 10 centimeter alone you take divided by 100, that is 12%. Here you have some powders, the rock breaks here, you do not get a piece. Is it clear? You core through the rock, you may not get rock as a single mass, you are getting only 3 pieces, sometimes 4 pieces, sometimes you will get a single piece of 1 meter, then core recovery and RQD is equal to 100%. That is a very good quality rock. So this gives some idea what is the type of rock. RQD is 0 for this particular thing, otherwise they would have given here RQD. Similarly it is moderately weathered rock. Which is a better rock, moderately weathered or highly weathered? Which is a better rock, highly weathered rock or moderately weathered rock? Moderately weathered rock is a better rock. Do not say highly means it is not good. Highly weathered means the weathering action is so much, the quality of the rock deteriorates. The proposed length of the jetty is about 235 meter on the back side and the front side is 255, it is some kind of a trapezium. We have a T diaphragm wall in the front, middle row of vertical piles and rear row of anchor diaphragm wall. This sometimes we call it as a dead man diaphragm wall also. The T diaphragm wall is 4 meter by 3.6 meter with 1000 mm thick web and 800 mm thick flange. This is 4 meter, this is 3.6 meter. This is called as the web, this is 1000 mm. This flange is 800 mm. We have the fender beam in front, they say that there is a fender beam in the front. The distance from this center line is not here, this is about 1.9 meter. So, we have a, we do not want the diaphragm wall on the face of the berth, because when the ship comes by some tilting it should not go and hit. So, there is a fender beam here, then there is a fender, afterwards the thing is here. This diameter is 1000 dia, this is spaced at 4 meters center to center. Flange center it is given as 9.4 meter. This distance is 10 meter, but this 9.4 meter I do not know whether it is correct or not, there may be some mistake in that, it must be 12 meter only, because we have a crane track here, center line of crane, there is another crane is there, because of that it may be like that. But anyhow it does not matter, the center to center distance between the crane track is 12 meter, this distance is 4 meter and this thickness is 1000 millimeter, is what is shown here. This main diaphragm wall is subjected to a lot of earth pressure and the deflection is to be reduced. What is the deflection for a simply supported beam subjected to point load P? This coefficient we will check, I think it is correct only, but does not matter. What is the unit of this? It will be in millimeters. It depends on Young's modulus and moment of inertia, and L is the span, P is the load. Then you have UDL means what is the load? What is the deflection? 5 by 384 WL power 4 by A. So, now the load acting on the diaphragm wall will be trapezium, not this. The boundary conditions are not like this, boundary conditions are different. So, you have to do analysis and find out what is the limit of deflection, how much you have to limit the deflection. Somebody was telling something. What is the limit for deflection? L by 20, that is depth. You are telling span by depth ratio. It is between L by 250 to L by 350. There are different cases during construction stage, during considering all the live loads and things like that. So, this is 17, that is 21, okay, but we do not know what is the span here, because it is going down below the seabed. So, we do not know the span. Suppose let us say that the span is about 25 meters, permissible deflection is for a 25 meter span 25 by 250 into 1000 is equal to 100 millimeters. 100 millimeter is how much? This will be 100 millimeter, I think, somewhere here like this will be about 100, maybe the cell phone size length may be 100 millimeters. the diaphragm wall permissible deflection can be 100 millimeter. How to control this deflection? The control of deflection is all the places high. If you increase the moment of inertia, your deflection will be reduced. One of the reason we put a T diaphragm wall is to increase the moment of inertia. Then another is Young's modulus. You cannot increase the Young's modulus very much, but if you go for a better grade of concrete, you can increase. So, we have gone in for M35 grade. Very difficult in the field to do more than M40 grade. So, we have gone for M35 grade. Then load can be reduced. Suppose the span between this is 4 meter, suppose you reduce it to 3 meter, the earth pressure acting will be only for a distance of 3 meters, the load will be reduced. So, we have to see all these things and correspondingly carry out the analysis. And top level is 3.85, the average bed level is existing 2.724. We have to design it for 100,000 DWT vessel with a draft of 14 meter and a design dredge level of minus 17 meters. I think they use M40 grade, not M35. Steel grade is Fe 500. We should get all these water levels, highest high water level, mean high water level spring, neap water level, mean sea level, mean low water spring, mean low water neap, chart datum, lowest water level. Somebody was asking how to fix the founding level of the diaphragm wall. We have to calculate the factor of safety. This is by considering the ratio of passive pressure, I have to say passive force, with the sum of active earth pressure force and differential water pressure, it should be greater than 2. This is the force due to passive earth pressure, this is force due to active earth pressure and due to differential water pressure. This is the earth pressure, active earth pressure depending on the soil parameters. This is the differential water pressure. So, you are given the water level here. We have assumed 0.3 meter. There is a procedure to calculate the water level on the seaside depending on the drainage condition. So, using that we have calculated the differential water level is about 1.455 meters. Using that you can calculate the differential water pressure. 58.2 is given here because 1.455 will give 14.55 kilonewton per meter square, but you have to multiply by 4 meters. Is it clear? Why 4 meters? Why do you have to multiply by 4 meters? That is the spacing between the piles. We do a typical section which is 4 meter wide. Center to center distance between the pile governs the typical section. That is why we multiplied by 4. That is 14.55 into 4 is 58.2. But the differential water pressure goes right down at the bottom. This is the passive earth pressure from minus 17 up to minus 25. Though we have given the founding level at minus 27, we have calculated originally we want to do at minus 25, we want to found it also at minus 25. This project IIT Madras is the design consultant. There is an independent engineer who is engaged by the developer and the Visakhapatnam Port Trust. Developer is ABG Group. This ABG Group and Visakhapatnam Port, they are engaging an independent engineer who will check the design of IIT Madras, and he wanted minus 27. So, we have provided minus 27. So, with this the factor of safety comes to about this is passive earth pressure is 14,145, this is 27,34, it is more than 5 I think. Then when you do the analysis, you have to do the analysis for different load combinations. 1.2 times dead load, 1.2 times live load, 1.5 times active earth pressure. Generally IS 465 code says 4651 only 1 times active earth pressure, whereas Visakhapatnam port in the tender document said because another structure has failed due to active earth pressure, they said you increase the factor, load factor to 1.5, 1 time the differential water pressure, 1.5 times the seismic force in the x direction. A, B, C, A is the main diaphragm wall, B is your piles, C is your anchor wall. These bending moments are in kilonewton meters, 35,500 kilonewton meters. Pile we are calculating at 2 different levels because the beam bottom is coming up to 1.1. We take the center line for idealization. So we can design only at the bottom level of the beam for the pile. Anchor wall is 31,500. Then for this is for maximum bending moment, one of the load combination. For maximum axial force there is another load combination. This is to find out the founding level of pile. This is limit state of collapse, this is limit state of serviceability. Limit state of collapse increase the load by a load factor, and this design is also different for the concrete. In limit state of serviceability you do not increase the load by any load factor, do the analysis for the actual load similar to working stress design, find out the maximum force coming on to the structure. For the pile, if the maximum force coming on the structure is 2900 kilonewton, the load is transferred by skin friction and end bearing, calculate the ultimate load that it can take and give you a factor of safety that should be more than this 2900. So, when you put a moving force combination, the maximum axial force comes for the main diaphragm wall. If you put the berthing force combination, you get the maximum force for the pile as well as for the anchor wall. That is why it is listed here. Any doubt in this? You have different forces acting: dead load, live load, berthing force, mooring force, seismic force, active earth pressure, differential water pressure, and you have to consider different load combinations. How many combinations we will analyze, do you think? How many combinations we will analyze? Guess a number. Huh? How many combinations you have to do? No, you just guess the number. How many load combinations we will do? We will do 120 combinations. Because we have the crane load, position of the crane load, different fenders. Finally, it comes like this. See, for limit state of serviceability, there are 2 cases that are given. One is the crack width, another is the deflection. Deflection should be less than L by 250 or L by 350 depending on various conditions. The crack width means whenever there is a concrete, the concrete will crack. You cannot see that the concrete will not crack, it will crack because there is a lot of stress that the steel will take. Steel will take up to 165 megapascal. This is the allowable stress, whereas actual stress will be 500 megapascal. How much will be the tensile strength of concrete? 0.7 times? What he is telling is right, 0.7 times root of FCK. 10% may be some approximate value, exact value is modulus of rupture, that is equal to the tensile strength only. Modulus of rupture is the tensile strength only, that only we use to calculate the gross moment of inertia. This 0.7 times root of FCK will be 3.5, suppose if it is 25 M25 grade, it will be 3.5 megapascal. Where is 3.5 megapascal, where is 165 megapascal? this permissible tensile strength of concrete is given in IS code for different grades also, that also you can check, that may be somewhere in the range of this modulus of rupture only, and that value you compare with this. So, the tensile strength of concrete is much less than the tensile stress in steel. So, the concrete will crack in tension. So, we have to neglect that concrete, but when it cracks there is some crack width. So, there are 3 zones, one is splash, intermediate and submerged zone. Splash zone means where the water level goes up and down, where we restrict the crack width to 0.1 mm. Then concrete has to flow between the reinforcement bars. For that the spacing between the bars should be greater than 100 millimeter. What will be the size of the coarse aggregate? Concrete consists of 3 parts, one is coarse aggregate, fine aggregate, cement, then you add water. What is the size of the coarse aggregate? 20 mm generally, sometimes they use 40 mm for plain concrete for foundations. 20 mm means the aggregate has to go, the distance should be more than 20 millimeter. Since we are doing it under water as well as below the seabed, minus 25 and all, we have to, the concrete has to go from the top. So, we need a spacing of greater than 100 mm. To achieve this we can use the bundled bars. Then what is the length of the reinforcement bar? See, reinforcement bar is coming and you are tying it and lowering it. What will be the length of the reinforcement bar? How much it is transported? Question is not clear. Bar is coming from the factory, from the shop, you are bringing it to the site. What will be the length, standard length? 12 meter is the standard length. 15 meter I do not know. So, they sometimes use only 6 meter length. That means if the diaphragm wall is from minus 27 to plus 1, 28 meter, there should be some lap. The lap should not be at the same place, you have to stagger the lap. These are the things which you have to do. This calculation I will discuss separately. This is the calculation to get the crack width. This is the result what you will be getting. This is the bending moment diagram in the pile. So, this bending moment diagram is done on the tension side, that means on this side there will be tension, here it will be on the other side. Suppose this is the water side, this is the land side, the reinforcement should be provided more on this side and this side. So, it should not be at the same face, but the circular pile we put uniform reinforcement. This is a typical spreadsheet which we prepare to calculate the reinforcement for piles. This also I will discuss later. This is a bending moment on the anchor wall. So, this shows that the reinforcement should be more on the sea side and less on the land side. This is for the T diaphragm wall, the reinforcement is only on one side, it is not on both the sides. There are 2 reinforcement given, one is for limit state of collapse, another is for limit state of serviceability. The detailing is very important. So, this reinforcements are given. Actually this reinforcement, this diaphragm wall is not same as what we have given here. I will skip this, it is slightly changed. So, this is all right. This is on the sea side, we put so much of reinforcement here. The spacing between the bars in this side as well as this side should be more than 100 millimeter. We have to provide some compressive bars also to tie these shear stirrups. Whenever you are designing, you have to design for both for bending and shear, and you have to provide some more shear stirrups also. What is called as a detailing. The reinforcement, if you see the anchor wall is more here, as you go down it is reduced and afterwards it goes to the other side. So, we have 4 sections here. So, as we are going down, this is the top section, this is one section below, 2 sections below and the bottommost section. As we are going down, we are reducing the number of reinforcement bars. when you go here your bending is on this side only. So, reinforcement is given where the tension is there, because concrete is weak in tension. This is for the pile also, as you go down the reinforcement is reduced. This is a tool which is used to cut the pile, to bore the pile. There is one moving trolley here, this is used with the tool along this direction to cut for diaphragm wall. This is the engineer who is standing just to show how the reinforcement is. So, this is your reinforcement in the anchor wall. This is the shape which we are giving for the anchor wall, not a rectangular thing. We have given some plates here because the soil was collapsing. To avoid the collapsing, they have put some steel plates as a shuttering built along with the reinforcement bars. Diaphragm wall in the rear is economical. We instead of putting in the main portion, because the surcharge load, if we take, it will be difficult. When you do the boring of concrete, it should not be more than 5%. The end stopper with steel plate attached to the reinforcement cage, what I shown in the slide, is required. We need a opening of 400 by 400 for lowering a tremie pipe for concreting. The minimum thickness of the diaphragm wall should be 600 mm, and thickness of flange and web, if it is same, it is better for T wall. Here we have suggested different thickness, subsequently we have revised. So, if it is same, then boring will become easy. Okay.